In this particular question, we're told that a toy car is allowed to roll down a straight inclined board. The force of gravity is such that the toy, starting at rest, accelerates down the ramp at a rate of 4 meters per second squared. We need to find the equation that describes the position of the toy on the ramp measured from its point of release in terms of times and seconds. So really what we need to find is the equation for displacement, where displacement is expressed in terms of time, and we've been told the acceleration of the toy car, which is 4 meters per second squared. Well, that acceleration is constant. So we know that a of t is equal to 4. To find v of t, which is our velocity equation, we'll take the antiderivative. So v of t is going to equal 4t plus c. c is the constant we need to find. But we're told some information. We're told that the toy starts at rest. That means at t equals 0, its velocity is 0. And based on that, we can say that c, that constant, must also be equal to 0. So therefore, v of t is equal to 4t. Now, we weren't asked for the velocity equation. We were asked for the displacement equation. So again, we'll have to take the antiderivative. In this case, s of t is going to be equal to 2t squared plus d, where d is another constant. Well, we were also told that this equation for the position of the toy, or the displacement of the toy, is to be measured from its point of release. Well, at t equals 0, that means my displacement, or s, is going to be equal to 0. So if I substitute those back into my displacement equation, what I would find is that d, that constant, is equal to 0, and therefore we can conclude that s of t, the equation for displacement with respect to time, is equal to 2t squared.